Hey everybody, I thought I'd share a visualization of the problem from today's class. So I have the sheet here in front of me, but we had the upper function. This is the first problem. It was sine of pi x, and that was the outside, and then the inside was 1.2 to the x minus 1. And I think the upper bound, I'll actually look at my calculator because I might still have it up. I'll have to go ahead and find the intersection again. Oops. So sine of pi x, and then we had 1.2 to the x minus 1. Oops. Oopsies. Minus 1. Then when I do second calc intersect, I think it was 0.9 something. It was this point of intersection. First curve, enter. Second curve, enter. Guess, enter. 0.940. Okay, so let's go back to this. So we will go to 0.940. Enter. So now we can see this. I think I want to zoom in a bit. What's going to be quite nice about this, it'll give us a nice visualization. So we want to rotate this. It was about the line y equals -1, right? It already tells us the volume. This automatically calculates it. That's the answer we had gotten in class, if you remember. But let's try to check this out using this. I think I got my whole thing. Okay, there we go. I think now I have it oriented correctly. We're going to rotate this around this axis, and I'm going to try to put it at an angle so we can see. So let me rotate very slowly so that we can sort of see what's happening. Hey Dante, how are you?
I'm fine. So I'm going to do repeat calculus ABX here.
Oh, nice. Congrats. I'm doing a video right now for my class, but I'll come talk to you in a minute. I'm excited to have you. Okay, so I'm doing this rotation here. So now you can sort of see the shape. I mean, imagine this were filled in. Remember how we said it was kind of like a donut? Well, you can see it's kind of got, oh, I think if I zoom in, it gets a little bit, here I'll have to do this all again, but if I zoom in, you can see it's got kind of like this more rigid edge on the inside, and then it'll be smooth on the top. So instead of these little discrete distances between, imagine this was perfectly filled in about all of them. Let me see, I'll go slowly. Bada bing, bada boom. And you can sort of get an idea of this shape here. It's going to be a shape like this. It gets cut off a little bit, but a three-dimensional, that's the figure we're finding the volume of. Hope this is helpful for some of you, and I'll post this right now so folks can see it. That's actually the shape we found that volume of 4.96 from class today. Have a great one.